So what does the number 720 look like when we prime factorize it? Okay, so let's break this down into its prime factors. So we're going to end up with 2 times 360. And again, you could break it up any way you want. You could do divide by 4 if you like, but I'm just going to divide by the smallest factor that I can see there, 2 and 180. Okay, so we're going to have 2 and 90. Okay, so here we get 9 times 10. Here we end up with 3 times 3. I'm just going to circle all the prime factors as I hit them so they don't lose track of them. Okay, that 10 can still be split up into 2 times 5. Okay, so those are all my factors, prime factors. So I can rewrite 720 as a product of prime factors as 2 times 2 times 2 times 2. It's a lot of 2's there. I'm going to group them like that and end up with 3 times 3. Okay, and then we have times 5. Okay, so that's a lot of 2's to write out. So there's a much more efficient way of writing this, and we can use an exponent to do this. So we're going to go 2 to the power 4 and times 3 to the power 2 times 5. Okay, so the exponent is very useful because it helps us with these big expansions. It allows us to not have to write out so many terms. And basically, it counts the number of multiplications. Okay, so that 4 is counting how often I use the base 2 to multiply. Okay, so this is an exponential expression. So an exponential expression basically has 2 parts. Okay, it has a base. Okay, so the bottom is called the base, and this is our multiplier. So the base 2 here means we're multiplying by 2. And the top part is called the power or the exponent. So we can say this is a 2 to the power 3, okay, or we can say this is 2 exponent 3. Okay, either way is perfectly fine. So, if you want to say it, I'm going to just write it like this: 2 to the power 3. Okay. Now this power again is just to counts how often we multiply. So that 3 means I've used 2 in multiplication 3 times. So when we have these exponents and we combine by multiplication, essentially all we really need to do is count out the multiplication. So we can just expand this out. So I have 3 squared is 3 times 3. 3 to the power 4 is 3 times 3 times 3 times 3. Okay, and then since it's all multiplication, everything is just connected by multiplication, I'm counting repeated multiplication. So I can just rewrite it as an exponent. I use the multiplier 3. I just can count them up 1, 2, 3, 4, 5, 6 times. Okay, so I write it as 3 to the power 6. 2 to the power 3 is going to look like this: 2 times 2 times 2. Okay, we have 3 times 3 times 3 times 3. Now, to write as exponent, well, I've got 2's here, and I can count up the 2's. I've got 3's, and I can count up the 3's. I cannot count these together because they're different things. So when I put this back in exponent form, I can't somehow combine these because I can't count 2's the same as 3's. So I have to count the 2's separately. It's 2 to the power 3, and I've got to count the 3's separately as 3 to the power 4. Okay, so when we write an exponent, we have to be clear that since we're counting the number of times we multiply by a base, we can only count one base at a time. So here, this is divide, but since exponents are counting times, really, they are related to division. In fact, we can undo multiplication with division. So I can write 3 times 3 times 3 times 3 times 3 on top. And in the denominator, I can have 3 times 3. And I know that one multiplication on top times by 3 cancels with the divide by 3. They undo each other. A times by 3 here undoes a divide by 3. So those cancel each other out. And so I'm left with 1, 2, 3's being multiplied. So I have 3 to the power 3. Well, if that's true, then I can just use the same reasoning here. I've got 3 times 3 on top. Okay, I've got 3 times 3 times 3 times 3 times 3 on bottom. And I know that multiplication and division undo each other. So those will undo each other. Those will undo each other. Now, anytime you undo a times with a divide, you're always going to be left with 1. That's what we call the multiplication division identity. So on the top, we have 1. Okay, so we're not left with 0 on top. Anytime things cancel with subtraction, we're left with 0. But when we cancel with division or multiplication, we're always left with 1. Now on the bottom here, we can just write this as, well, I've got 3. I can just count the divides on the bottom as 3 to the power 3. That just means I have 3 divides, which makes sense. If we can count multiplication with exponents, we can count division as well, and we count division in the denominator. Okay, so as long as we understand the top is times, the bottom is divide, this makes perfect sense. I have an extra 3 divide by 3's because it's in the denominator. Okay, so that's perfectly fine. So that's a very important thing that we should remember, is that times is top, bottom is divide. So when we have these fractions, if we have extra divides, we just write them as, count them in the denominator, and that would give us an appropriate use of exponents when we're counting divide. So exponent count on top is going to be counting times, and the bottom is going to be divide. And we can cancel things out if we have the same multiplier or divisor, if we have the same base.